Hello friends, in this video we are going to have a discussion on the sprinkler system on board ship and the associated parts of it. What are the bulbs, quartzoid bulbs which are there, and what is the color coding of it, working principle of the sprinkler system, as well as the maintenance schedule of the sprinkler system. We are going to have a discussion. Okay, sprinkler system. A sprinkler system is nothing but automatic fixed firefighting installation, or you can say that it is automatic fire detecting alarm and extinguishing system which can deal quickly and effectively with the outbreak of the fire which may occur in the accommodation space or the other spaces of the ship. The system consists of the several sections comprising the number of sprinkler heads which is mounted on the pipes on each section through the section control valve, and this is the sprinkler main which in turn connected to a pressure tank or the pump. When we will see the constructional detail, we will come to know all this part. And for each section, you can say the maximum number of the heads which can install be 200, and each section is also having the alarm also associated in the section. Okay, the entire system is initially charged with the fresh water, means we have the fresh water arrangement available about the pressure of 8 bar by the tank which is half filled with the fresh water, and on top you have the air arrangement. Okay, so it is basically pressurizing and keeping it pressurized, and it is maintained under pressure by the compressed air. This should be such that the pressure at the highest sprinkler head in the system is not less than 4.8 bar. This is the system requirement. It also connected to the independent seawater pump which is with its own seawater suction. Means once this, suppose the fire is large and the fresh water is being exhausted or finished, then you have the seawater which is there already. So the system is there and the seawater pump also starts and start giving water on it. Under specific pressure maintained by the tank and by the air pressure, the water from the sprinkler is deflected outwards and broken into the fine spray by the serrated edge of the sprinkler base. Basically, the spraying of the water is done with the help of the nozzles, or you can say the sprinkler heads, which is being designed on that, and the deflector plates are doing the thing. Okay, the coverage area as per the SOLAS requirement, coverage area of the floor is about 16 square meters, and the coverage rate is approximately 5 liters per meter square per minute. Okay, now we can see over here the sprinkler head is attached with a quarterized bulb which is retaining basically a diaphragm seal, and this diaphragm seal is holding the valve system, and it holds the water in the pipeline because all the time the pipeline is being pressurized. When the quarterized bulbs are manufactured, there is a small gap which is being left behind, or the liquid is being filled up. After that, there is a small gap in which the gas space is left, so that the bulb is subjected to heat. When it is being subjected to heat, the liquid will expand and the gas space is diminishes. So the due to the heat, the liquid will expand and the gas will be pressurized or diminishes, and then the bulb will be shatter. This will generate a pressure inside the bulb and the bulb will shatter when the predetermined temperature is being reached. Okay, so when we talk about the general operating range, it is 68 degrees centigrade to the 93 degree centigrade. On the higher temperature, bulbs are also being found, and it is being installed as per the space requirement. We will see that thing. Okay, when the bulb will burst, the water pressure forces the diaphragm out and the water flows out of the sprinkler. This is the main working part of the sprinkler head. Okay, here we are going to see about the basic working principle of the sprinkler system complete, as this diagram explanation you can say that. Okay, so here you can see this is your pressurized tank, this is your complete pressurized tank, and we have the fresh water installed in that, and the compressed air which is coming from here, which is also there, and if the water reduces, the fresh water supply is also there. The pressure gauge we can see over here, and the relief valve is also seen over here. Okay, you can see that this is the non-return stop valve B, which is already locked open, and here in this section, let's suppose in this section we talk about, so this is valve A, that is also locked open. Okay, so in these valves are there, and this is the complete section. We have the sprinkler heads which is installed in the section. Okay, and this is a testing valve C. So testing valve C is basically utilized for the purpose of testing the alarm of that particular section. If we open that, then water start flowing into this, and we will see that how the alarm also works. So that will give you the audio visual alarm for that particular section. Okay, so we can test without operating the heads, we can test over it. Okay, and same like that you can see the other sections are also installed over here. Okay, and this is the pressure relay which is fitted on this. Okay, and if any engine room water spray system which is there, so that from that also you can have the connection. System drain line completely drained. When the pressure drops to 5 bar, then your seawater pump will start. Here you can see the salt water pump or seawater pump. There is a C section, and once it is being sensed, the signal will go to that and the water supply from there. So this is also locked open, and water supply will come over here, seawater supply, and go to the section. So this drain valve is that once you have done that one, then it must be drained and pre-washed. Okay, and for pump testing valve, you can do the testing of the pump. Opening that, the pressure will reduce, and then the pump testing is being done. Pump will start automatically, and this is your hose connection which we talked about. That is also there. Okay, so once you see this diagram, you can by seeing this also it can be explained nicely. Okay, so now we'll go to next slide. In this slide, we are going to have the explanation of your sprinkler head itself, how actually it looks like, what is happening. You can see over there, this is the deflector plate. Okay, and this is your complete frame. We can see over here, and this is your temperature sensitive glass bulb which will shatter and the water start flowing over here. This is your sealing assembly which we can see. This is your sealing assembly which holds the water. Okay, size of the glass bulb in this one, it is quick response 3 mm bulb, standard response 5 mm bulb. You can see over there the color coding which is also given over here. Okay, so this is your orange one, 57 degree centigrade. This is your red color one, 68, yellow 79, green 93, blue 141, and this deep blue, it's 182 degree centigrade. So what happened, this connection is done on the pipe, and through which the pipe, this your water is coming over there, and this pressurizes the diaphragm, and actually this quartzoid bulb holds it on place, and no water is flowing into this. But what happened once the temperature is rising into the compartment, this temperature sensitive bulb will inside that the liquid will expand, and once the liquid will expand, the volumetric expansion will there, and this will create a huge pressure, and the bulb will shatter. Once the bulb will shatter, diaphragm will comes out, and the water start flowing into this. Okay, so this water will fall on the deflector, and in the form of a sprinkler it will spray into the area and cover also area and extinguishes the fire. Okay, here you can see that the same thing. If you have to see the diagram part of it, here the water is there, and this is your the diaphragm which is there, and this is the valve which holds the diaphragm in the place, and these are the threads through which it is being attached to the pipeline, and you have the quartzoid bulb which holds the valve, and valve holds the diaphragm, and this is the deflector plate which is shown over there, and this is the complete yoke. So for drawing purpose, you can utilize this diagram. Okay, and here you can see that the red is 68 and 80 degree centigrade is yellow, 93 green, 141 blue, and 182 violet. So these are the color codings which is associated with it. Okay, what are the system alarm valve? Okay, when the sprinkler head comes into operation, the non-return valve for the section opens and the water flows into the sprinkler head. Okay, so this is the section valve. We are talking about the section, each section. This non-return valve also uncovers the small bore alarm pipe head, and the water passes through the little bore alarm pipe to the rubber diaphragm, and the water pressure acts on the diaphragm, and this operates a switch which causes the break in continuously live circuit, and this will give you the alarm. Both audio and visual alarm which is fitted in the engine room, bridge, and the crew space are being automatically operated. Okay, so how the alarm comes, that is being explained over. Okay, as we have seen in the previous slide that how the non-return valve operates. So in this one actual functioning we are going to see over here. First of all, I am going to tell you about the description of the parts which you can see. This is the non-return valve, you can see, and this is the basically valve blade over here. Okay, and this is the stop valve which is locked open, and once the this side your sprinkler heads are being attached. Here it is written 150, but basically as per the regulation now it is 200 maximum number of heads can be installed over here. This is the pressure gauge installation. This is the pressure alarm switch which is fitted over here. Okay, this is the filter arrangement. Okay, and here the test valve arrangement and drain valve and plug. Okay, so this is something which is the a complete arrangement of the sprinkler head non-return valve. Okay, so what happens once the sprinkler starts operating over here, the water starts flowing into this side. Okay, and you can see over here this is something which is pressurizing, and this valve completely non-return valve which you can see is lift up. Okay, and you can see over here this is the stopper which is being provided. Okay, and here you have the thing which is going and attached to it. Once it will go and sit over here. Okay, and then this space and this space will be open. Okay, so the what happened, the water will gushes towards this side. Okay, and it will go and operate the sprinkler. But what happened, as it goes up, this uncovers this portion. Okay, once this uncovers, so due to this the water flows inside this also. Once through this filter it is passing over here, and this is going to pressurize. Once it's going to pressurize, you can see over here this also. So this is going to break the circuit, and the test alarm will work, or the alarm for that particular system will work. Okay, so this works basically the water which is passing through this small bore pipe and the pressure alarm switch, this also get activated. So this will give you the audio visual alarm. Okay, now further to it, does the pressure drop at the release of the water causes the alarm to sound. Okay, so we have just seen of that, and this will indicate on the bridge on board. Okay, and the zone in which it has ruptured of the sprinkler head, that is also being described. Means the sprinklers are described into the different zones. So what happened when it is it's operated, so that particular zone audio visual alarm will come. Okay, when the system pressure dropped to 5 bar, means the pressure which is there in the your tank and the complete system, if it is sensed by the pressure switch that it is dropped to 5 bar or less than that, then the seawater pump automatically gets signal and it will start supplying the seawater. Okay, the hose connection is also provided so that the water can be supplied to the system from the source. Suppose if not possible in dry dock to operate these pumps, and also you have the source connection facility also, which we have seen in the main diagram. The sprinkler heads are spaced not more than 4 meters apart and 2 meters from the bulkhead. Okay, so the installation time that has to be taken care of, that between two sprinkler the 4 meters at least distance is being required, and from the bulkhead at least 2 meter distance is being required. Okay, the stop valve A and B, which we have seen in the main diagram, is locked open, and if either of these valves are inadvertently closed, a switch will be operated that brings the alarm into the operation. Means to say that when we talk about this has to be locked open, and if it is being all closed, so the arrangement is given that it will give the alarm on the bridge. The alarm system can be tried by opening the valve C, which allows the delivery of water similar to that of the one sprinkler head to flow to the drain. Okay, means when we have to try out the alarm, so this test alarm valve is to be operated, that is C. At least two sources of power must be provided to operate the seawater pump and automatic alarms. Okay, so we have the main supply system, that is with the main generators, and the emergency supply system also there. Okay, the components are being tested weekly on this sprinkler system. Okay, now we are going to see the requirements of the water sprinkler system on board ship. Okay, as we know that this is the automatic system which works without the interference of the human, as well as it is something which is the audio visual alarm as well as the fire extinguishing system. Means to say that it is basically your detection system also, as well as it is your extinguishing system also. Okay, now we are going to see the requirements. Okay, each sprinkler head must be capable of delivering water at the rate of 5 liters per meter square per minute. Okay, each sprinkler head is sufficient to cover the area of about 16 square meters. Okay, one section is permitted to contain maximum 200 of heads. Okay, the pressure at the highest sprinkler head in the system is not less than 4.8 bar. Okay, the sprinkler head are spaced not more than 4 meter apart and 2 meter from the vertical wall. Okay, these are the SOLAS guidelines. Okay, and continuation with this, these must be at least two power sources at seawater pump and alarm system and freshwater pump. That means the main power supply and the emergency. Okay, the system consists of independent seawater pump which with its own seawater suction. A separate seawater suction is being required for the seawater pump attached to it. Section alarm can be tested individually by the test cock on each section. Okay, now we are going to see how this quarterized bulb operates. So what is the principle of operating these bulbs? Principle is Belvy. Okay, Belvy. This is something which is boiling liquid expanding vapor explosion. It is an explosion caused by the rupture of the vessel containing the pressurized liquid above its boiling point. So it is basically the gas which is the space which is being left little bit when the temperature will rise, so the liquid will expand and it will pressurize the bulb and further rupture the bulb. Okay, how the sprinkler head operates. Okay, so explanation of this also, so these are asked in the orals sometimes. Okay, so it is being explained over here. Each sprinkler head is made up of the steel case fitted with the water deflector. We have seen the diagram earlier. A quarterized bulb which contains the highly expandable liquid and is retained by the cage. Okay, the upper end of the bulb pressed against the valve assembly which incorporates a soft metal seal also that is there. When cauterized bulbs are being manufactured, a small gas space is left inside the bulb so that if the bulb is subjected to heat, the liquid will expand and the gas diminishes. This will generate the pressure inside the bulb and the bulb will shatter once the predetermined temperature is being reached. Okay, so I hope you guys have understood. It is already explained in the earlier slides also. Okay, once the bulb shatter the valve assembly, it falls and the permitting water to be discharged from the head which strikes the deflector plate and sprays over a considerable area, or you can say the coverage area as per the requirement. Okay, so operating range, generally the temperature range of the cauterized bulbs are 68 to 93 but the upper limit of temperature can be increased also, as we have seen in the earlier part. Cauterized bulbs are manufactured in the different color which indicates the temperature rating of the bulb, which we have seen also in the earlier slide. As per the various temperature range, we have the different color of the bulbs. Okay. Okay, now we are going to see about the maintenance and the testing part of it. Okay, so weekly testing and inspections. So we have to verify all the control panel indicators and alarms that should be functional. Visually inspect the pump unit and its fittings. Check the pump unit valve positions if valves are not blocked as applicable. Okay, so visual inspection of the complete system has to be done on the weekly basis, and all the fittings, all the valves and all the pump control panel indicators, that has to be. In continuation, now monthly testing. Verify all control pump unit and the section valves are in proper open or closed position. So in continuation with that monthly also we have to continue with this practice. Verify sprinkler pressure tanks or the other beans have the correct level of water or correct pressure. Test automatic starting arrangement on all system pumps so designed. Okay, so when we have the automatic system, so the automatic operation must be tested monthly basis. Verify all standby pressure and the air gas pressure gauges within the proper pressure range. Sometimes these are malfunctioning also, so if required change it, otherwise we have to check it that it has to be working properly. Test the selected sample of system section valve for the flow and proper initiation of the alarms. So that means the alarm testing, we have the each and every section, we have the test valve, so we have to test it as per the matrix. Note the valve section for testing should be chosen to ensure that all valves are tested within 1 area period. So we have the 1 year combined period, and in that one all valve must be tested. Okay, so now the annual testing, monthly, what we have seen, it has to be continued. Okay, and annual testing, in addition to that, verify the proper operation of the water mist or water spray or the sprinkler system using the test valve for each section. That is again continued, and the visually inspect all accessible components of the proper condition. That means the visual inspection again continued over here. Externally examine all high pressure cylinders for evidence of damage or corrosion. Okay, so if at all any high pressure vessels which we have seen, we have to maintain the pressure at 8 bar, so that has to be visually examined. Check that the hydrostatic test date for all high pressure cylinders has to be maintained. Functionally test all fixed audible and visual alarm system. Okay. Flow test of the pumps for the proper pressure and capacity. Okay. So high pressure cylinders means to say that the pressure vessels which is attached. Test all antifreeze system for adequate freeze protection. Means for this we have the antifreezing liquid which is put over there in the tank. Test all system cross connections to other sources of water supply or proper operation. That means we have the other valve from the, suppose in dry dock we don't have the seawater pump operations or the freshwater pump operations, so we have to take the water from the other sources, so that valve conditions and the things are to be in proper condition. Verify all pump relief valves if provided are must be properly set. Okay, and examine all filters, strainers to verify they are free of debris and contamination. Verify all control section valves are in correct position. Okay. Now continuation of annual testing. The dry compressed air, we have to blow it and nitrogen through the discharge piping or the dry pipe system, or otherwise confirm the pipe work and the nozzle are clear of the obstructions. And this is also there. Basically these are done by the authorized service centers, and we have to see the complete operation and clearing of the nozzles and the pipelines. Okay, if applicable, test emergency power supply switchover. Okay, so in annual we have to see that we know that as per the SOLAS guidelines we have to have the main power supply as well as emergency, so we have to test the emergency supply. Okay, visually inspect all sprinkler focusing in the area where sprinklers are subjected to aggressive atmosphere. Okay, so sprinklers, all the sprinklers inspection must be done. Okay, all sprinklers are inspected within 1 year system. We have to make a program so that the sprinkler heads must be visually inspected for the proper functioning of that. The sprinklers with obvious external damage including paint must be replaced. Suppose it is being painted or any external damage you are observing by the visual part of it, so it must be replaced. Check for any changes that affects the system, such as obstructions, ducts, pipes. If these things are there, must be removed. Test a minimum of one section in each open head water mist system by flowing the water through the nozzles. At least each section, one section must be operated. The section test should be chosen so that all sections are tested within the 5-year period. Okay, so when we are talking about actual water flow and all, so we have to test in such a manner that all the sections are completed within 5 year of period. Test automatic and automatic water mist nozzles in accordance with the flow chart, or further if you want to refer, you can refer the MSc circular 1516. Now 5-year service, and including the annual service, plus all the Roro deluxe system piping with the water. Suppose in the Roro system we have the pipelines and all, so the drains, the pipelines and all these things has to be checked, and it has to be purged with the air. Perform internal inspection of all control section valves. Okay, check condition of any batteries or renew in accordance with the manufacturer recommendation. Suppose for the control panel or anything, anywhere any batteries are being there, so 5-yearly period it must be renewed. 10-yearly, these systems should be inspected and tested by the competent person as the manufacturer instructions, including annual, including 5-yearly, everything. And as a minimum should be included, perform the hydrostatic test and the internal examination of gas and water pressure cylinders. Okay, so the vessels which are there, which is being pressurized, So hydrostatic pressure testing must be done at 10 yearly basis, and the requirement, if you are going for that, then it is EN 1968-2002. That is the requirement for hydraulic testing of the gas, hydraulic testing of for gas and water pressure cylinders. Hope now you guys have understood the sprinkler system, operation of the sprinkler system, operation of the your non-return valve and the audio visual alarm system, the sprinkler head, how it is being operated, the maintenance as per the SOLAS guideline, that is your weekly, monthly, and in continuation with that annually, then 5 yearly and 10 yearly. So in this video, I hope all these things are being explained nicely and you guys have understood. Thank you.